Welcome to ESSR's initial lead awareness course. Thank you for taking the time to attend this course. This training will provide a basic understanding of the University of Maryland's approach to staying safe while working around lead, a well-known health hazard. It is designed to meet the requirements of the Occupational Safety and Health Administration's, or OSHA's, Lead Standard 29 CFR 1910-1025. The objectives of this course include understanding lead, how you can be exposed to lead and where it is on campus, how lead exposure can affect your health, what are some of the ways to prevent such exposures, lastly, what to do if you believe you've been exposed to lead. By the end of this course, you will understand the health hazards associated with lead exposure and have valuable knowledge and tools to work safely around toxic lead. The OSHA Standard 1910-1025 says that since we have lead on campus, we have potential exposure to lead at any level. Therefore, we must be informed of Appendices A and B of the standard. What are Appendices A and B? Appendix A covers substance identification and health hazard data. We will discuss what lead is, its common uses, how lead can enter our bodies, how much we can be exposed to, and how overexposure can affect us. We'll also discuss the contents of Appendix B, such as permissible exposure limits, or PEL, personal protective equipment, PPE, and housekeeping practices. A lot of what Appendix B covers is what lead abatement workers would be doing to remove lead from campus, but they're considered necessary topics to cover to have a better understanding of lead and how we would protect ourselves from it. Lead is a naturally occurring, heavy, bluish metal that has been used for centuries in a lot of products. It is nearly indestructible and not biodegradable. Lead cannot be rendered harmless. All of its forms, all states of its matter, can affect our bodies and health. It is very important to note that although we have very small amounts of lead already in our bodies, it is toxic to the human body. Lead has been used for many hundreds of years, and we have even recognized the hazards it can cause. Historically, lead found in storage vessels, paints, and glazings, and printing inks were identified to be toxic to people using these items. Lead was commonly used in many everyday applications. It was used in gasoline, auto manufacturing, and smelting, to name a few. On campus, lead can primarily be found in lead-acid batteries, and the main use regarding lead in paints and coatings. Lead was used in paint because it increased tensile strength, prevented insect and mold infestations, made the paint more malleable, protected against UV rays, and helped maintain its pigmentation. In 1978, the Consumer Product Safety Commission banned the use of lead in residential paint and paint used in the construction of public buildings. As a result of this ban, buildings built after 1978 are not considered to be a risk for lead contamination from paint. Many maintenance activities, such as sanding, scraping, and welding, were previously considered non-hazardous and routine. Now we know if lead is present on or in the surfaces being disturbed, workers and occupants of the area where the work is being performed may be exposed to lead. Because lead-based paint is the primary risk for lead exposure to UMD employees, it is important to know where it can be found on campus. Lead-based paint has been used in many of the buildings on campus, but is most commonly found on exterior surfaces. Paint preparation, such as scraping and sanding of these surfaces, can generate significant personal exposures. Housekeepers cleaning lead paint dust and chips are also at risk. Examples of lead-based painted surfaces on campus include the following: the white roll-up door at the wind tunnel building, exterior door trim at the Cole Student Activities building. Notice the deterioration of the paint, the signs of cracking and chipping. Surfaces such as the painted Maryland sign at the Cole Student Activities building. The exterior stairs at the Engineering Laboratory building. This example shows how lead paint can rub off each time employees held the handrail. The lead-based paint here has since been abated and repainted. The interior stairs at Prinkert Hall. the white doors, windows, and door trim at the apiary, the window trim at the chemistry building. Notice the deterioration of the paint, which can lead to dust and chips. Part of Appendix A is understanding the health hazard data of lead, including ways in which lead enters your body. Lead can be absorbed into your body by inhalation and ingestion. A portion of lead gets into the bloodstream, circulates throughout the body, and is stored in various organs and body tissues. When absorbed into your body in certain doses, lead is a toxic substance. As exposure increases, the amount of lead stored in the body increases. This stored lead can slowly cause irreversible damage, first to individual cells, then to organs, and then to whole body systems. Lead is a potent systemic poison that serves no known useful function once absorbed by your body. Taken in large enough doses, lead can kill you in a matter of days. Some acute or short-term health effects include brain effects, coma, convulsions, and even death. Please keep in mind these health effects occur when you are exposed to lead in large doses. Chronic or long-term overexposure to lead may result in severe damage to blood-forming, nervous, urinary, and reproductive systems. Symptoms include loss of appetite, metallic taste in the mouth, constipation, nausea, headaches, and many more. A metallic taste in your mouth is a clear sign you are being exposed to some type of heavy metal in the workplace, and that metal is most likely lead. Some of the more common chronic health effects are damage to the central nervous system in general and to the brain. Chronic overexposure to lead also results in kidney disease and can impair the reproductive systems of both men and women. How lead affects children is a major concern. Developing fetuses and young children are most at risk for damage due to lead poisoning, which may cause irreversible damage to the developing nervous system, resulting in behavioral and learning problems. Other effects lead may have on children are slowed growth, hearing problems, and kidney damage. We now know that lead levels in the body, in concentrations much lower than previously thought, can be responsible for many of these problems. UMD is responsible to determine if any employee may be exposed to lead at or above the action level of 30 micrograms per meter cubed. If this level is reached, exposure monitoring, medical surveillance, and additional training and education are required for the employee. Additionally, no employee shall be exposed to lead at concentrations greater than 50 micrograms per cubic meter of air averaged over an 8-hour period. When this level is reached, corrective actions such as engineering controls, training, work practices, PPE, hygiene facilities, warning signs, and personal air monitoring must be implemented. It is important to note that exposure monitoring at UMD has been conducted, and there are no known operations with exposures exceeding the AL or PEL for our employees to date. Other lead limits of importance include the OSHA blood lead levels, or BLL. Up to 40 micrograms per deciliter of lead is allowable in our blood, while 50 micrograms per deciliter require immediate medical removal from work. Additionally, lead in drinking water can be up to 15 parts per billion. Note how all lead levels are lower for children when compared to adults. Blood lead levels are a key factor regarding your exposure to lead. They are the most useful indicator of the amount of lead being absorbed by your body, as they represent the likelihood that you will gradually acquire a lead-related health impairment or disease. If you develop signs or symptoms associated with lead poisoning, or if you desire medical advice concerning the effects of current or past exposure to lead on your health and/or your ability to have a healthy child, immediately notify your supervisor. Also, notify your supervisor if you have difficulty breathing during a respirator fit test or while wearing a respirator. In each of these cases, your employer must make appropriate medical examinations or consultations available to you. Now that we know more about lead and its potentially harmful effects on our bodies, let's discuss some methods of compliance to reduce and/or eliminate our exposure. When you are tasked with working with painted surfaces in older buildings, you should confirm the absence of lead in the paint and always use proper hygiene and housekeeping procedures. PPE may also be necessary. Employees should contact their supervisors and/or ESSR prior to the disturbance of painted surfaces. An XRF analyzer can be used to determine if lead is present in or on a surface, or paint chip analysis can be done at a laboratory. For XRF analysis, paint containing lead levels of more than 0.7 milligrams per square centimeter is considered to be lead paint according to Maryland state regulations. When paint chip analysis is done, paint containing lead levels of 0.5% or more by weight, also reported as 5,000 parts per million, is considered to be lead paint. Because we work in environments where lead is present, we also need to know the restricted practices involved with working around lead. Practices such as open flame burning, torch cutting, or using machines without the proper attachments to collect dust can be dangerous work practices. Additionally, we need to understand there is a difference between abatement and replacement or removal. Abatement is a measure designed to permanently eliminate or remove the lead from the building component. Removing a building component intact or whole that has lead on it or in it is not abatement. This is considered replacement or simply removal of the building component. On campus, there may be times we need to clean up paint chips, dust, or debris. This is especially the case for our housekeepers. There are certain work practices we must use to limit the amount of dust we create. Using wet wiping methods and high-efficiency particulate air, or HEPA vacuums, is key to eliminating possible lead exposure during cleanup. As mentioned, using a high-efficiency particulate air, or HEPA-filtered vacuum, is a recommended work practice when cleaning up. We should never use an ordinary vacuum to pick up lead or any toxic dust. Although we may never be exposed to lead above the PEL of 50 micrograms per cubic meter, we can still follow good hygiene practices to ensure we do not absorb, ingest, or inhale any lead dust. Keep this in mind when we are eating, smoking, and/or applying cosmetics. Don't forget to handle, store, and dispose of contaminated materials properly so we don't take lead dust to our automobiles and/or homes. PPE use is only required if an employee is exposed to lead above the PEL, but is still always a good work practice when coming into contact with any levels of lead. Coveralls or similar work clothing, gloves, hats, shoes, face shields, and/or safety glasses or goggles can be worn to protect against exposure. Respirators should be worn when exposure to lead is not controlled below the PEL by other methods, such as engineering controls or work practices, and only after you've met the requirements for properly wearing a respirator. Disposal of lead-contaminated waste can be handled by ESSR or a third-party contractor. ESSR can provide approved drums, drum liners, containers, and labels required for the proper disposal of hazardous materials. If you think you've been exposed to lead, immediately notify your supervisor and report the event to ESSR for investigation. Complete the university's first report of injury as documentation of the potential exposure. Additionally, you may be medically evaluated depending on the investigation. Keep in mind, lead can also affect us at home. If your home was built before 1978, it may contain lead-based paint. The same safe work practices we've discussed can and should be used at home as well. Other examples of potential lead exposures existing outside the workplace include some everyday items and activities, such as handling stained glass and ceramic glazing, or from target shooting or making fishing weights. We've just covered a lot of topics about lead in this training. Now let's review some of these topics. We learned about the characteristics of lead, why it is used, and some everyday components containing lead, such as paints and batteries. We gained an understanding of what is included in the OSHA lead standard appendices A and B. In covering them, we became aware of UMD operations that could result in lead exposure. These operations include sanding or grinding surfaces with lead-containing paint and cleaning up lead-containing chips, dust, or debris. We learned how short and long-term lead exposure affects our bodily systems, especially how it affects children. We also learned what are considered safe levels of lead exposure in the air we breathe, the water we drink, and most importantly, the levels of lead in our blood. We discussed some protective measures to implement to avoid lead exposure. These measures included using HEPA vacuums and attachments, wet wiping methods, and proper hygiene practices. In addition, we reviewed some examples of PPE you can use to protect yourself from exposure. Lastly, we discussed what to do if you suspect you have been exposed to lead and/or have experienced any symptoms associated with lead exposure. If you have any questions regarding lead on our campus and would like to learn more, please contact ESSR at 301-405-3960. Thank you for completing this annual lead awareness training session, and stay safe.